Hello class, in this video we're going to talk about the idea of the algorithm in determining the linear regression model. So as we discussed in a class, let me first clean this. So as we discussed in a class, if you give me the linear model which is described here, if we know the beta 0 and beta 1, then for each data point, then we can calculate the predict price. And the formula is beta 0, the constant, plus the number of rooms multiplied by the coefficient of number of rooms. And we need to log this beta 1, that's coefficient. See, for this room, for this data point which has 8.78 number of rooms, the predict value or predict house price is 46. So there is a difference between this actual house price and our predict value, which we call it a residual. The actual price minus the 50 value. For all the data point we have, for each data point we have, there is a residual terms. And our goal is to choose a beta 0 and beta 1 to minimize those residuals. But as you see, there is negative and positive. And if you sum directly, they would cancel out. So in order to avoid that, what they do is to use the square of the residuals. And then we replicate this formula to all the cells. And then we want to minimize the square of the residuals. So we take the sum of these terms. And this is the residual associated with this model. And if we choose a different model, say 30s, then we will have a different value for residuals. As you see, it increased from 16,000 to, if we change the beta 0 to 30, then it increases the residuals. So our goal is to find a set of beta 0 and beta 1 to minimize these residuals, so that will be our best model to fit this data. And we can do it by two-way data table, because we have two parameters here, beta 0 and beta 1. So suppose in a row we put the the beta 0. We take the step of 2 and we check this all the way to say 44. In the column we put the value of beta 1 from 1 to say 15. And in the column we tell the model, the data table, what we want to calculate. And then we highlight this region by click Ctrl A. Oh, Ctrl A doesn't work, so I have to let's choose this region and then go to data. What if analysis data table? In the row input cell we have this because this beta 0 is in the row, so we choose the row input cell as beta 0 and column input cell as beta 1, and we press OK. We're going to use a conditional format to help us identify the one, give us the row list residuals, the bottom one. As you see here, the coefficient to minimize the residual sum of residual square is minus 38 and 9 beta. So the beta 1 should be 9 and the beta 0 should be negative 34. So this is what the program is doing in when they're trying to do a linear regression to determine the beta 0 and beta 1. So instead of doing this complicated data table, what we can do is just use the Excel data analysis tool to get the coefficients for linear regression. We go to data analysis, regression. In the Y input cell, we're going to in the Y input cell, we're going to choose our house price. In the X input cell, we're going to choose the number of rooms. And we have to check the label because we put the first row as the label. I want to choose the output range as here. This is the place we're going to put our result. Then you click OK. Then you get a result. As you see here, the coefficient intercept beta 0 is negative 34, and the number of rooms, the coefficient for number of rooms is 8.9, which is close to line. So this is exactly what the program is doing when you hit the linear regression. And let's look at the coefficient here. As you see, the coefficient, as within a class, the coefficient has p-value. Let me write it down. P-value is less than 0.05, so it's significant, which means the number of rooms has a significant impact on the house price. Or you can also look at the lower and upper interval. As you see, 0 is not in this interval, so it always have a positive impact on house price. And the coefficient will tells you what exactly that impact it is. So the coefficient here is a 8.9. That means increasing one number of room would increase the housing price by $8,930 because the unit for the y variable is $1,000. And so that's the output for linear regression, and how we interpret the coefficient for these x variables. So that's the video for the single unit model. In next video, we'll talk about multivariate model and linear regression.